Everyone. And Unit 2. They are going to see about heat treatment. In this chapter, first of all, heat treatment. It is a process of heating metal below molten state and cooling the metal, which is controlled away to select desired mechanical properties. What are the purpose of heat treatment? To harden and strengthen metals, to relieve internal stress, to improve machinability, to improve ductility and toughness, to increase wear and corrosion resistance of metals, to improve the electrical magnetic properties, and to refine grain size. The types of heat treatment process, that is annealing process. First one, the types annealing process, normalizing, hardening, tempering, and martembering, and case hardening. It has such as carburizing, nitrating, cyaniding, cyaniding, carbon nitrating, flame hardening, and induction hardening. That's annealing. It involves to heating the predetermined temperature, holding at the temperature and then cooling at very low rates. Annealing, it is classified as full annealing, stress relief annealing, recrystallization, perisodizing, and full annealing. It is consists of heating steel to above upper critical condition. It is suitable to higher carbon steel. It is hold the steel at selective temperature and above upper critical temperature. It requires long time and expensive method. The purpose of this full annealing is refine grains and remove the strains, improve the machinability, formality, formability, electrical and magnetic properties. The next one is stress relief annealing. It is used for after treatment to inner rest within the cast during the further manufacturing. It relieves the stress produced casting, plunging, machining and cold work etc. It applies the equally well to ferrous and non-ferrous metals. Recrystallization annealing. It is carried out with up to the temperature for 600 to 700 degrees centigrade and heating the critical temperature and slow cooling. It is also temperature is not fixed for treatment used in sheet and wire industries. It is used to reduce the dissociation of crystal lattice produced by cold. Next one, periodizing annealing. The heating the steel to temperature above critical point and holding at the temperature followed by slow cooling. That's up to within the furnace of 600 degrees centigrade. That's a shown that the dotted shows the figure that the temperature will be increases for special temperature, that is 725 degrees centigrade, that prevents the cracking of steel during the cloud forming operation, which can be obtained. Next, normalizing. The steel is heated to about 400, it's not, sorry, 40 degree to 50 degree above upper critical temperature held at sufficient period of time. Next, the purpose. It refines the grain structure to obtain the homogeneous structure, decrease the residual stress, improve machinability. Next, tempering. It is a heat treatment process followed by fast the involves after hardening, while the hardened steel to some temperature below and low critical temperature, soaking at this temperature for sufficient time followed. In this to relieve the stress and improve the ductility for the hardened steel. The high temperature tempering will be about 500 to 600 degrees centigrade for 10 better tensile strength and impact strength. And also this type, the structure should be very soft and toughness. As timbering. It is, it is also the treatment process to obtain for basanite structure the heating the steel, the alternating temperature which is 725 centigrade to 1370 centigrade, and also have the temperature for long time to needed for transformation. And since the quenching the bath temperature is higher than ms temperature, it's a purpose for residual stress reduce, less hardening, cracks, wastage, and also thick section cannot be treated. It is for temperature is used as the thermal formation of long time. These are the flowchart for the as tempering. That is the transformation which finally it is slowly increases at the surface of finite temperature. And also this is a marine. This is the transformation will be decreases while the term word in desired marsenite. While the case hardening, while first is surface hardening, the hardening is use various elements, carbide, nitricities, surfaces formed the components. The various process, carburizing, nitrating, carbon nitrating. The carburization should be takes place the following reaction, that basanate carbon plus BaO plus CO2, and CO2 again reaction with carbon, which is carbon dioxide for dissociation of CO2. Then this enrichment cell should be added. The carbon dioxide should be reacted with CO plus iron plus Fe2 plus Fe3 plus C plus CO2. By the advantages, it is more efficient and cheapest method. This is not suitable for thin cases. It does not provide close control. More time it is required. And liquid carbon, it is 20% to 450% sodium cyanide and 40% sodium carbonate, and varying the amount of barium chloride. And the mixture is melted and bath temperature, it is varied between 815 degree to 900 degree. The following reaction with that barium chloride plus sodium cyanide, it is Ba into Cn plus NaCl. Again, it is advantage, it is uniform heat transfer and less time only required, and also low dissociation. Disadvantage, the cyanide salt are highly poisonous. The parts should thoroughly wash after treatment to preventing rushing. And gas carburizing, it is heated as 900 degrees centigrade for 3 to 4 hours. The steel is heated and contact with hydrocarbon, the methane and ethane with carrier gas. The following reactions will take place for gas carbon, that is Fe plus CO plus H2 use iron carbon plus water, and also again reacts with iron with carbon oxide. It is heated iron carbon plus carbon dioxide. That is the advantage. The advantages are less time required, less labor cost, and also suitable for main mass production. In disadvantage, the highly skilled, the labors are required. There's a nitride. Next one is nitride. It is a process of coating steel surface with nitrogen ammonia gas and coated on surface plate with 400, 480 degrees centigrade to 650 degrees centigrade at the temperature. And then it is filled with ammonia. The first of furnaces takes place for raised for temperature. to 0.2 to 0.4 mm deep. As a, the flow ender with gas outlet pipe to inner gas inlet. That the restart the way the furnace will be again nitrides with applied for medium carbon steel alloys containing aluminum, chromium, and molybdenum, etc. As an advantage, this is high surface hardness, corrosion resistance, good fatigue resistance, no machining is required, and no quenching is obtained. Disadvantage, it requires more time and cost ammonia is high. Long cycle time and hard and brittle. Cyanidation is the process of both combination of carbon and nitrogen added to the surface layer. It is left as 0.1 to 0.2 mm. So you have to see in the picture the furnace is closed with heat. While heating the specimen of the cyanide is placed in the center portion, it is a waste mixed with the energize. The heat is packed and cyanide temperature, the cyanide will be boiling. The components are imposed with the 30% of NaCN and 40% nitrogen oxide. The measured amount of air should be passed through molten part and temperature would be held at 30 minutes to 3 hours. The again reaction will take place or NaCN plus CO2 gives Na2 CO3 plus CO plus nitrogen. Ion will again react with carbon. Gives iron carbon plus carbon dioxide. Iron plus nitrogen gives iron nitride. It is advantage to increase surface hardness and increases wear resistant fatigue limits. Application. It is suitable for small parts, gear, piston, etc. Actually, carbon nitrogen. It is a heat treatment process by which carbon nitrogen while ammonia gas which is the layer of steel component. The process involvement the temperature is 850 degree followed by quenching of oil and solution. While you are seeing the picture, while the furnace, the neutral gases are preheated and then again processed with carbonitrate salt. While inserting that carbonizing gas, ammonia gas are reheated with for 850 degrees centigrade. The neutral gases should be quenched and the wastage should be go outlet. The air mixture should be methane and the mixture of ammonia 15% and remaining neutral gas. The advantages is low sponge needed and reduce distortion. Application it is used to bolt, nuts, gears, etc. That's all. Thank you.